Hello, let's take a look at a problem similar to your homework assignment from section 4.5. We have a table that gives us some information about a drug test. It gives us the positive results and negative results and broken down by the number of subjects who use drugs versus those who don't use drugs. And then they're asking us to find the probability that somebody gets a negative result given that they use drugs, and then they want us to find the probability that somebody uses drugs given that they got a negative result. And they want to know if these are equal, and we'll soon find out that they're not going to be. They're not necessarily going to be equal to each other. So we have a table, and the first thing we want to do is we want to add up the row and column totals. So we'll do the addition. 44 plus 6 is 50. 90 plus 860 is 950, and so the grand total looks like it's going to be 1,000, but let's double check that. 44 and 90 is 134, and 860 plus 6 is 866, and if we add these two, we can confirm that we actually do get 1,000. All right, now for the first problem, it's a conditional probability. There are several ways to do this. I think the simplest way to do this is to take a look at the subject uses drugs, and since this is the second one that comes up, this would be our kind of like our denominator, our grand total. So we want to look for the people who use drugs. So subject who uses drugs, there's 50 of them here, and so we're selecting, given that we're selecting from the pool of people who actually are drug users. Now, what they want to do is they want to find the number of people who had negative results. So a negative result out of these 50 people who got negative results, there's only 6 of them. So our result should be 6 out of 50. Now, another way to do this is to actually use the formula for um, the conditional probability, and that is that formula is equal to the probability that somebody gets a negative result and they use drugs, divided by the probability that they actually use drugs. So what are these probabilities equal to? The probability that they get a negative result and they use drugs, that is going to be a probability that they get negative results and then they use drugs is going to be 6 out of 1,000. And then the probability that they use drugs is 50 out of 1,000. And you see that this actually simplifies if you do the um, multiplying by the reciprocal kind of business. You see that we're going to get the same result. All right, so if we're looking for a numerical value out of this, we can pull out our calculators and find out what 6 divided by 50 is, and then we get 0.12. So there's a 12% chance that somebody who does not use drugs, out of all the people who don't use drugs, that they're going to get a negative result. All right, so let's get to the second problem. Find the probability when a subject, find the probability that we select somebody who uses drugs, given that they had a negative result. So if we use this first format of finding it, we want the number of people who got negative results. That's going to be our grand total pool, and so that pool is 134. And then out of all the 134, oh, I'm sorry, this should be 866 because we're looking at the negative. So let's try that again. This is 866. And out of those 866 people who got negative results, how many of them actually use drugs? how many of them actually use drugs, and there are 6 of them. So there's 6 out of 866. And so I think you can tell that there's going to be a big difference between these numbers, but let's just confirm that with a calculator when we divide 6 divided by 866. If I can get my calculator here. All right. So we're looking at 6 divided by 866, and we get 0.0069. So let's go 0.007. So clearly they are not equal to each other because when we take from a different pool, we're going to get different results. Okay. So I hope this helps, and good luck.